Hey class, we're going on to 5.2, finding probabilities in the normal distribution. These are the word problems that are associated with the last section basically. And these we'll be doing two steps. First, we're going to take a raw score and convert it to a z-score. And we have a formula for that from the last section. And then we're going to either use technology or the table to find the area. So let's do an example. So suppose we want to find the probability of x greater than 120, and we know the mean is 100 and the standard deviation is 15. So let's do the two steps. So first we're going to get the z-score, and that's this formula right here. Now the x I'm going to use is 120, because I want the z-score corresponding to 120. Even though it says greater than 120, I'm going to get the z-score, and then I can figure out the area from there. And then the mean is 100. Standard deviation is 15. Make sure to subtract first and then divide. So this is about 1.33. And then you can use the table if you want, or I'm just going to use StatCrunch like I did last section. Okay, so I go to StatCrunch. Remember where it is? If you just open a blank StatCrunch page, if you go to Stat, Calculator, Normal, there it is. Okay, and then this one is greater than, so I have to switch that inequality around to greater than. And I put in my 1.33. And then compute. And I get the correct answer of 0.0918. Okay, so then 0.0918 would be the final answer. Right? That's a probability that we have a value that's greater than 120. Now I did that in two steps because I did want to get that z-score. If you don't really need that z-score, you might have noticed in StatCrunch, you could do it all at once. So if I go back to StatCrunch, because notice the mean and the standard deviation you can change. So if I change that mean to 100, oops, I put 200, and then the standard deviation 15, then I'm not putting a z-score here, I'm putting 120. And then compute. And I get a slightly different answer, 0.0912. And that's because when I put in the 1.33 before, I actually did some rounding. It was really 1.33333333. So this is actually more accurate, 0.0912. Okay. And turns out StatCrunch, MyLab should accept either of those answers. So you could do it just all at once in your StatCrunch, or take it piece by piece. I'm showing the piece by piece because sometimes it's going to ask for that z-score. And if you do it all at once, you don't get the z-score, you only get the final answer. So it's good to know both. But I mean, that's the gist of this section, really. So we can now just try some different examples, right? So here's one where we have, let's see, you're always searching for the mean and the standard deviation. There's the mean, there's the standard deviation, find probabilities. So if you want to find z-scores, go for it. I'll do one with a z-score. All right, so if I need the z-score, I would just go 66 from the question, 69.6 for the mean, and 3.0. And that's equal to negative 1.20. Okay. And then I'm going to, since it says less than, that indicates the inequality I need to use in StatCrunch. And then I'm just going to go do it in StatCrunch. So back over to StatCrunch. So I'm going to change, if I'm doing z-scores, I got to make sure that mean is 0 and the standard deviation is 1. And then that one was less than, so I got to change my inequality to a less than, and then we got negative 1.2 return. Okay, so I get 0.1151. right? So that would be the two-step approach that we've been doing. The all-at-once approach is I would actually put in the actual mean, which was 69.6 for this problem. My fingers never really work with this iPad. And then the standard deviation is 3. And then, instead of a z-score here, you're going to actually put the number that's in the question. Right? In this case, it was 66. That is a height less than 66. And you'll notice you get the same answer, 0.1151. Okay, so either way, that one, because we didn't have to round the z-score, both worked out to be the same. Okay, so I kind of prefer that second method unless I need the z. I mean, if you need the z, you gotta, there's really no StatCrunch way to do it. You just gotta use that formula. But if you don't need the z, you can get right to the answer. Right? So how about B and C? Let's go do those. So between 66 and 72. So for that one, I gotta click the between option. And I've got my mean and standard deviation already there. So then I'm just putting in 66, 72, compute, and I'm good to go. All right, I get it. That's the 0.6731. Okay. So 0.6731. Right, and that's it. Okay. How about more than 72? Go back to StatCrunch. More than 72, I gotta go back to standard. And then I gotta switch my inequality around to more than. And then change the 66 to 72. And then compute. And I get 2119 on that one. 0.2119. 0.29. Got it. Okay, so it's really all in StatCrunch. And then what are you finding? Again, you know, like don't lose the big picture, but if we have a normal distribution and we have the mean and the standard deviation, we could find percentage of adults pretty much within any range we want. Less than 66, between these two, right? So that last one, more than 72 inches, it's basically 21% of the population is taller than 72 inches. Okay, let's try another one. So here we got to search for mean, 24.2, standard deviation, 4.3, and away we go. Right, and then we have the questions. So let's just do it all with StatCrunch, and then I'll transfer the answers over. So I go to my StatCrunch page. I got to change the mean, 24.2, standard deviation was 4.3, right, and then we have it. And then less than 18. So I gotta change it to a less than 18, compute. Right, and we get 0.0747. 0747 for that one. 0.0747. All right, so there's really no work to do. All right, just got to translate it to StatCrunch. How about between 20 and 29? Between. Going between 20 and 29. Compute, and I get 7035. Okay. Done. I'm gonna go whip through these pretty fast. How about more than 33? Okay, I gotta go back to standard. I need more than, that's greater than 33. Compute. 0204. That's what we're gonna have to do in that one, huh? If I round to the 4 decimals, I'm gonna go 0204. And then are any of these probabilities unusual? Okay, so we kind of have two ways to do it. You can look at the z-score, which we didn't find on these, or if the probability is less than 5%, we can do that. So it looks like part C is good, because it's only 2%. All right, that one will be unusual. The others look more than 5%, so that's that one. Okay, and then how about this? If we have if 200 high school students are randomly selected, how many would you expect to get a score of less than 20? All right, so first we have to find the percentage of less than 20, which we haven't found yet. Right? So for less than 20, let's go back to StatCrunch and get that percentage. So I'm going to go less than 20, compute, and I get 0.1643. So I'm going to go 0.1643, 0.1643, and then that's the percentage of students we would expect. If we have 200 of them, I'm just going to multiply that by 200 to figure out the actual number of them, right? And then I gotta find my calculator. Where's my calculator? There it is. You can't see me searching frantically for my calculator, but I did, and I get 32.86. And then this is the number of students, right? So this is about 33 students we would expect. All right. Okay, so there you go. 5.2. Rely heavily on StatCrunch. StatCrunch is your friend, and give them a go. If you have questions, let me know. Otherwise, I'll see you in the next section. Thanks. Talk to you later. Bye.